now I'm going to talk a little bit about the special things that are true for right triangles, i.e. the properties of trigonometry. Now, I want to make sure that, again, this should be a review, but that some terminology is clear. So when we talk about the hypotenuse, that is the longest side of the triangle, and that is the side opposite of the right angle here. And again, as I've used previously in some of the geometry, whenever you have a triangle, you know all of the sides add to 180. So if you have a right triangle, that means that this is 90, so the other two must add to 90. So in this case, theta plus phi is equal to 90. And since this gets a little confusing with the notation, this symbol here, I would write it by hand that way, but you can also write it that way. Many people do. And you can call that either phi or phi. It's the same letter. And if you think that that is completely mind-boggling, just keep in mind that when you look at this, you know that's a letter A and that that is also a letter A. There's just certain letters that we write them different ways. This happens to be a Greek letter that we write in two different ways. So please don't let that confuse you too much. Use whatever you are most comfortable with. I can recognize both of these. So another thing to know about this, as I've already underlined, is that we have the Pythagorean theorem. And that tells you that your length of the hypotenuse squared is equal to the length of one side squared plus the other side squared. So you can only use this for right triangles. You can't use this for whatever triangle you want. So again, be careful that you don't have a scenario where you haven't constructed a right triangle and you're just plugging random variables in here. The other thing to be careful about, I realize that, depending on what math classes you've had and how long ago they were, maybe you haven't used this in a while. And a common mistake is to look at that equation and say, yeah, C is equal to A plus B. That is definitely not true. C is then equal to the square root of A squared plus B squared. I'm sure that you can do the algebra to get between these two lines, but please don't work so fast that you're making simple mistakes. Okay. Now, this is perhaps the slide where we cover the meat of trigonometry. Again, my assumption here is that this information isn't completely new to you. I'm just hoping to jog whatever bells, have been unrung for a while. So the first is the mnemonic SoHCA. It's my experience that almost all students have heard of this before, but I want to make sure that everyone's on the same page. When someone tells you SoHCA, they're talking about a trigonometric mnemonic where each of these three letters is telling you how the functions are defined. Sine, S in SO, is defined as the opposite over the hypotenuse. So this is your SO. Cosine is adjacent over hypotenuse, which is Ka. And tan is opposite over adjacent, Toa. And where this comes from, when we're talking about opposite, hypotenuse, and adjacent, hypotenuse is always this longest side. That's easy. But now, what you have to do is say, what theta are we actually looking at? And in this picture, we have this one. And I keep coming back to having a picture because something you need to be careful about is theta might be this upper angle. There's nothing wrong with that. And so we talk about opposite and opposite and adjacent, meaning opposite to this angle. So this is adjacent to this angle, this side. And here I'm referring to the side. This side B is opposite to this angle. If we had the other one defined as theta, these would flip in which one is opposite and which one is adjacent. So please be careful about that, and if SoHCA is new to you, you'll probably hear your classmates say it. So that's what they're talking about. So something to keep in mind is that these should have the same units. So for instance, centimeters or meters for both of them. That way the units cancel. If we want to go backwards for any one of these, for instance, I could just invert this and say that theta is equal to the inverse sine, and this doesn't mean 1 over sine, this is specifically the inverse sine function of the opposite over hypotenuse. And another way that you might see this written is just arcsine Both of these are inverse functions to get the angle from knowing what the sides are. So another thing that you will frequently need to do is actually solve for one of these. So if, for instance, I want to find what the adjacent side value is, I would probably want to use this equation, and I can say that hypotenuse times cosine of theta is going to be equal to my adjacent side. And I just got that from doing algebra. So in one slide, this is everything you need to know about the trigonometric functions. You will be using the inverse, which I typically call inverse, but again, they're also just arcsine functions, so you might need arcsine, arccos, arctangent. We typically don't get into the hyperbolic trig functions or cosecant or anything like that. So you've possibly learned many more functions than this in previous classes, but these are the only three that we'll need to use in here, and their inverses. So again, make sure that you get this right, and if this is something that you maybe mess up once in a while, feel free to actually write this out. Either write out SoHCA, or if you're about to do something involving an angle, feel free to write out sine of theta equals opposite over hypotenuse. That is fine. I would rather see in your problem-solving work that you started by defining sine wrong and doing everything after that correctly than not see how you've defined sine and never understand why you've made a mistake in your work. So you don't have to actually define this as a starting point, but if it's something that you occasionally make mistakes on, feel free to just write it down to clarify to yourself what the definition is. So the last thing that I want to talk about here, I know that many of you might be very comfortable with the unit circle, or at least maybe it's one of the pieces of trig that you feel more comfortable with. And I don't usually talk about the unit circle, but something that might be helpful to realize is that when we're using trig to break vectors into components, this is just like the unit circle. But instead of the radius of the circle having a value of 1, the radius is given by the magnitude of the vector. And then we can think about the y component. So this is going to be my a sub y value here, is simply given by sine of your angle, this opening angle with respect to the x-axis, times your magnitude, and then your x component here is given by the cosine. And again, this is the side that's adjacent to the angle, so it should be cosine. This is the side that's opposite to the angle, so it should be sine. And if this notation is new to you, this is covered in a later video, but in this point I just want to point out that when we're breaking things into components, when we're forming triangles, when we're doing all of the trigonometry, and most of the trig we will do in this class looks just like this, of breaking this vector into its x and y pieces, that this might be something you've learned in terms of the unit circle. So feel free to apply that if this helps. Otherwise, if the unit circle was not something you felt comfortable with, but you otherwise feel okay with trigonometry and geometry, don't feel like you need to go back and review that. So there are really 3 takeaways that I want you to have from this video, and I want you to feel comfortable with. And if this video was not enough for you to review these, please seek out additional resources. First, you need to be able to use those geometric relationships, again I refer to them as the x shapes and the z shapes, to determine missing angles, and you're going to need to do that all of the time, just in the process of the rest of your work. The second thing to remember is that those trigonometric rules and the Pythagorean theorem only apply for right triangles. So make sure when you're starting to bust out those math tools you feel really comfortable with, that you actually have a right triangle in front of you to apply it to. If you don't, there's ways, of course, of breaking up any triangle into right triangles, or you might be able to use a different mathematical tool. In general, in here, I never use the law of cosines. You're welcome to, which is something more generally true, but I always just break things into right triangles. Lastly, when we're working with vectors, we're going to be breaking them into components. This is something that will happen consistently for velocity, acceleration, and forces. So that's really about half of our entire class. We are going to constantly be using those tools from geometry, as I've shown you with those forces, and those trig tools of working with sine and cosine, taking the inverse, converting perhaps between degrees and radians. So be ready to do this all the time. It won't be like a math class where I might specifically say, find this missing angle. You're going to, for instance, need to recognize that you need to use trig and find missing angles, even though the problem hasn't explicitly told you that.